I'm back again. Okay, so we've just gone through the stoichiometry and how the ratio of moles to kilojoules is always the same. I'm going to use the same equation just to do some trickier calculations in this video. So I'm going to use glucose plus oxygen, excuse me, oh my gosh, sorry about that. Glucose plus oxygen goes to carbon dioxide plus water. I haven't put the states in here. They would be in an actual question. And we remember that the delta H was negative 2H2O kilojoules per mole. Right, so we're remembering that the ratio of moles to kilojoules is constant. So if we are asked a question about moles, we can do that reasonably easy. So for example, if the question said, if I burnt, because this is a combustion reaction, if I burnt, and let's just pick out a number, 7.82 moles of glucose, how much energy would be released? Okay, so that's my first question. So it's quite simple because it's given me the question in moles. And the first thing I need to do is go glucose. So the question is asking me about glucose, so I want to find glucose in my equation here. This is glucose here. So from the equation, I know that 1 mole of glucose releases 2,820 kilojoules. So that is my established ratio. 1 mole of glucose releases 2,820 kilojoules. So I've got 7.82 moles of glucose. So I'm going to go therefore 7.82 moles of glucose, and I have to keep this ratio the same. So if it's 1 to 2,820. So remember in the last video we said if I burnt 10 moles of glucose, I'd have to release 10 times more kilojoules of energy. So this is 7.82 moles. So it's 7.82 times more. So this is a little bit easy. So I've multiplied that by 7.82. So I need to multiply the kilojoules by 7.82 to keep that ratio constant. So I just get my handy calculator and I go 7.82 times 2,820, and that gives me 22,052.4 kilojoules. So I'm going to answer the question. If I burnt 7.82 moles of glucose, how much energy is released? This many. So therefore 22,052.4 kilojoules are released. And even though this is not an excellence question, I'm going to practice rounding this to 3 significant figures. So we start here, 1, 2, 3. And because that's a 5, we're going to round that up. So I'm going to go 22,100 kilojoules to 3 significant figures. Right, so that one wasn't too bad. But quite often they won't give you this number in moles. So let's try one that's not in moles. So let's say if I burnt 8.92 grams of glucose, how much energy is released? Okay, so this is a bit trickier because it's given me the question in grams, and this is quite common. So remember my ratio is moles to kilojoules, not grams to kilojoules. So my first job is to convert the grams of glucose to moles of glucose. And to do that, I use my trusty N equals M over M. You must always remember this one because it is a very, very important, very important formula that you do get given it in the resource sheet, but you need to know what the letters stand for. So moles, mass, and molar mass. So the molar mass of glucose is, I'm just going to make this up, but I think it's 180 grams per mole. So I've got the number of moles is equal to 8.92 grams, which is the little m or the mass, divided by 180 grams per mole, which is the big M. You'll get given this, you won't need to calculate this, which is the big M molar mass. And so that's going to be quite a small number, so 8.92 0.92 divided by 180. That gives me 0.04955. So I am not going to truncate that number. I'm going to keep it as long as I can to start with to make my last answer as accurate as possible. Right, so now from the equation, again, I'm working on glucose. So I know I've got 1 mole of glucose from my equation up here. So 1 mole of glucose equals 2,820 kilojoules. And I have only got 0.04955 blah 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 moles of glucose. So this is quite a bit smaller than 1. So I know I've had to divide it by something. So I need to find out, what did I divide 1 by to get to 0.04955? So let's go 1 divided by 0.04955 equals, I had to divide it by 20. Now, if I'm unsure about how to do this, I just want to check this here, right? These are my only 2 numbers. So I either had to go 1 divided by that or 1 times that. And actually, either of these ways would work out, but I'm just going to check my maths here. Does 1 divided by 20.18 equal that? So I'm going to go to my calculator. 1 divided by 20.18 equals, yes, it does. It equals the right number. So I've got the right number here. So now once I've got that, that's the tricky bit. I need to do the same to this side. 20.18. So 2,820 divided by 20.18 equals, oops, oh, yep, that's right, equals 139.74. It looked a bit funny to me, but then I thought about it. So does it make sense that if I burn 1 mole of glucose, I release 2,820? And if I burn a whole lot less, 20 times less, then I release 139? Yeah, that looks reasonable to me. So just remember to round your answer to 3 significant figures. So that's actually 1, 2, 3, but that needs to be rounded up. So that's 140 kilojoules are released. Oops, sorry, 140 kilojoules are released, and that's to 3 significant figures. So I'm going to stop here, but there's another couple of types of calculations that you might need to do. So those are kind of reasonably simple ones. So I'll come back and do another couple of types of calculations in just 1 minute.